Welcome to EDU World Space.
A, we should say what is the exploratory variable. So the exploratory variable usually is the one that we have in the x-axis or the one that we use to predict the other variable. So basically, from the question, we have that it is written that in this case, they build a model that predicts like fat content using protein content. So like I said, the exploratory variable is the one that is used to predict the other variable. So the variable that is being used to predict the fat content is the protein content. So the protein content is the exploratory variable. So in this case, we already have that the variable that we are predicting, which is the response variable, in this case is the fat content. So now, in item C, we should say if the scatter plot that we have, it seems linear, and if you have outliers. So basically what we need to check if you imagine a line, a straight line, in here, like we have the dots, a lot of dots, then we have like two dots here. So if you can imagine that like there is like a linear relationship that could be like increasing, like in this direction, or decreasing in this direction. So basically, we want to check if you can see one of these two lines. And from the scatter plot, we can basically see like it appears that we have like something like this. Of course, there are some dots here that like could be above this line, but like in general, it seems linear. So the answer for this question will be yes, it seems linear. In terms of outliers, we can see that these two dots, they are like really, not really far, but they are like a little bit far from the others. So like we can say that we have like two possible outliers. I don't know if they are influential because as you can see, they are still like they follow the same behavior, like they are in the same direction as the straight line here. So basically, what I mean by that they could be outliers, but maybe not influential. So now for item D, we should state the Pearson correlation coefficient and also make interpretation. So the coefficient here is the one that is given by R in the output, which is 0.82 to 827. So what we should look here is that this value is positive, and it is like quite high because this value could be like between -1 and 1. If it is close to either -1 and 1, or 1 in this case, this means that the linear relationship between the variables is strong. So in our case, what we can say is that the relationship here between these two variables here is positive because like we have a positive coefficient, and because it is close to 1, we can say strong as well. Now for item E, we should, in this case, write the equation. So basically, the equation is given by the parameter estimates. So we should plug here. First, we can put that this is the fat content that we are like predicting. And usually put hat to express that this is like a model. It's not like it's something that we are estimating. It's not something that is totally true. We have some kind of error. So that's why that we put this hat. Then we put the value of the intercept, which is 641. Then the value of the slope, 0.97, or in this case, 98, times the variable that is the exploratory variable, so the protein. So this is the model that we have. We are estimating, or in this case, it's better to say predicting, the fat content using this equation here, in which we use the protein content as well. For letter F, we should make an interpretation about the R square. So the R square here is basically the square of the correlation coefficient. So it's the square of this number here that we have. So this basically means that this will be a value between 0 and 1 always. So 0.6839. But in the interpretation, we usually use the percentage in this case. So 68.39%, and the interpretation is about the variability. So we have that this amount, 68% of the variability of our response variable. So in this case, of fat content here, is being explained, in this case, is explained by the explanatory variable, so by the protein content. So this is the interpretation, how we make an interpretation about the R-square. They give us like the percentage of the variability of our response variable that is being explained by the explanatory variable. In item G, we should give an interpretation about the slope if the slope is significant. So in this case, the p-value in relationship related to the slope, as you can see, like in the row, we have that the p-value here is small, usually like smaller than 5% will be enough. And this means that we can make an interpretation, because if the p-value is small, this means that we have a significant, in this case, value for the slope. So the slope is significant. So basically, the way that we make interpretation about the slope is that for every 1 unit, so for every increase of, in this case, 1 gram, because it is how the protein is measured. So for every increase of 1 gram of protein content here, we can expect, in this case, on average, we always talk about averages here, because again, we are like estimating something. On average, an increase. Why an increase? Because the value of the slope is positive. An increase of, and then we put the value of the slope, 0.98. Grams, because the fat content is also measured in grams in the response variable, in the fat content. So basically what I mean by this is that for the parts that are important is for every increase of 1 gram for our in this case, explanatory variable, we can expect on average an increase, and then we have the value here of the slope in the response variable.